you should have a graph that looks like this. What is the domain here? 0 to infinity. Guys, silence. You're in school. Turn on silent. What's the range? All real numbers. Negative infinity to infinity. Where's your vertical asymptote? X equals 0. And your x-intercept. If you can't see it on the graph, go back to your table. Your x-intercept would be where y equals 0. What is that point? 1, 0. All right, we talked about this a little bit yesterday. Okay? I'm going to tell you here, end behavior and asymptotic behavior are limit statements. You only need to write one for each because you only have two sides of your function, yes? End behavior would be when x is either going to, it's going to the edge of your graph. It's going to infinity or negative infinity. Asymptotic behavior, what word do you see in that? Asymptote. So that would be the side that the function is going to your asymptote. So if we take a look here, let's look at the left side first. Are we going to the end of the graph or towards the asymptote? Asymptote. So we're going to write our limit statement under asymptotic behavior. So the limit as x is approaching, what is the asymptote? 0. Good. We got to put in that plus sign because we're coming from the positive side of the graph, the right side of the graph. And I'm going to write in the other side for the end behavior because x is going to infinity there. So here's your limit statements. Write them out without putting in what your function is doing just yet. If you already filled it in, great. Some of us want to take it step by step. That's okay. As we look at our graph, as our function is approaching the asymptote, where is our function going? Negative infinity. So I'm going to put a negative infinity here. As our function is going to, or as our x value is going to infinity, our function is going to infinity. It's going up. Questions? No? We're okay? All right, so that's the parent function. We're going to use this for all our notes today, on this side at least. Yesterday we talked about transformations. Look at number 2. Who can tell me one transformation that we have?
Right 1.
Right 1. So we get that right here. Right 1. And? Connor?
Translation up 2, or 3.
Up 3. Good. Translate up 3. Now, I'm not going to make you plug and chug like yesterday. How many of us were like, oh my gosh, what was she saying? Okay. If we move right 1 on our graph, if we go right 1, what's going to be affected? The x's or the y's? X's, right? So if we're going right 1, we're adding 1. So I'm going to come here to my table and add 1 to each of these x values. So what is 1 plus 1/9?
1 and 1/9.
1 and 1/9. So I'm going to write 1 and 1/9. 1/3 plus 1. 1 and 1/3. 1 plus 1. 3 plus 1. 9 plus 1. Okay, do we see where I got those x values from?
Yes.
Yes, anyone confused? Tell me now.
But is that going to be on the test?
You can easily do it though, because we can see here we have the base of 3. And we can easily say, oh, I can come here and say 3 to my y is equal to x, plug in y values from -2 to 2. So plug in exponents to get those, and then you can easily shift them. You can, and I'm going to tell you this now, how many points do you need to graph? 3. So you can easily plug in 3, and you know what a log is going to look like. So you can easily do it with just finding 3 points and then shifting them like that. Should take you probably 30 seconds at most.
So are you just getting like the 119 from the parent function? Like I'm confused. Are you getting the
1 and 1/9 I got right here from the parent function.
Okay.
So then I just added my 1 because I shifted 1. Lily?
So like, one is branched off from the parent function.
I'm sorry, what?
One is branched off from the parent function.
Yes. So I'm moving my parent function here. The -1 inside the parentheses tells me move it right 1. Okay? Other questions? All right, up 3, what is that going to affect? The y. So I'm going to come here to my parent function. What is -2 plus 3? 1. -1 plus 3. 0 plus 3. 1 plus 3. 2 plus 3. 5. Let me ask you this. Knowing that we went right 1, our original asymptote was at x equals 0. Where is it now? X equals 1. So go ahead and make, this is why I want you to draw in your asymptote so you can kind of see, oh, I know how I'm shifting now. Go ahead and plot your points of this graph.
How did you get the asymptote?
Because we said right 1, it's originally at 0, so we're just moving it right 1.
Okay, so it would always be this.
If you have a horizontal translation. So whenever you go left or right, it's going to affect the vertical asymptote. Oops. Did I graph it right?
Yes.
Yes. What's my domain here? 1 to infinity. Good. You already told me the asymptote is that x equals 1. Range is always all real numbers, -infinity to infinity. X-intercept. This one is tricky. Okay? We know it has to be at y equals 0. If you notice, my numbers are all going in order for my y's, yes? 1, 2, 3, 4, 5. So your y-intercept is going to be 1 more less, right? It's going to be 1 less here. So what's the next smallest fraction of 3? 1 over 27. Okay? This is a tough one. I'm telling you now, this is a tough one. That's why I'm telling you it, not having you figure it out. They will be easier, okay, on the homework. They will be easier on the assessments, okay? So don't freak out about that one. They will be obvious in your table, okay? So here, I'm just going to write that down, 1 and 1/27th, comma 0. See if you can fill in the end behavior and the asymptotic behavior real quick. See if you can do that. When you finish, look up and check your answer. See if you got it correct. Thumbs up? Yes? Good? Questions? Ashley?
For the end behavior, why didn't you write 2? Did you just write 1?
For, oh,
Because like, I
and
always write both of them and then like transfer the.
because, so end behavior is talking about where is it going to the end of the graph, where asymptotic behavior is going towards the asymptote.
So I just write the asymptote.
Yep, and you know what? If you're writing them both, if you want to, if you just want to put an arrow down, that'd be fine for me. But it's like, yeah. So one is the end behavior, where it's at the end of the graph. The other one is where is it at the asymptote. So you only need to write one for each. Make sense? Questions? All right. How are we doing with the analyzing? We're good with the characteristics? Yes? All right, go ahead and describe your transformations. So what is one thing here? Reflect how? Reflect over the x, good. So negative in front here says reflect over the x-axis. And what else do we have, Connor?
A translation of 2 units left.
Left 2 units, good. We're just going to abbreviate that there. Reflecting over the x-axis. If I come back to my parent function, if I reflected this over, so I'm just looking at this arrow up here. If I reflected it over, what is going to change? X or Y's? Y's. How do the Y's change?
Negatives.
They go and change the sign, right? So if they're positive, they become negative. This one, they're negative down here, so they're going to become positive. So the Y's are going to change. So I'm, again, looking at my parent function. Okay? And I'm going to say, okay, negative 2 becomes positive 2. Negative 1 becomes positive 1. 0 stays the same. Negative 1 and negative 2. Yes? One step at a time. Okay, left 2. What does left 2 affect? X's, okay? Since we're going left 2, are we adding or subtracting 2? Subtracting 2. Now, this might be a little confusing, okay? Might be a little confusing filling the table because we have fractions. So maybe what I'm going to tell you is, again, how many points do you need to graph? 3. So let's just come here. Let's go to the other side. What is 9 minus 2? 7. So 9 minus 2 here. Got 7. What is 3 minus 2? 1. What is 1 minus 2? Negative 1. Do you have 3 points? Yes. So do I need to actually do the fractions? No. But you could. I'm going to put those in there. I'm going to tell you this. Okay? 1/3 minus 2 is negative 1 and 2/3. 1/9 minus 2 is negative 1 and 8/9. So if you want those in there, you can. Where is my vertical asymptote at? X equals negative 2. So I'm going to draw that in there. And go ahead and plot your points. Plot your points. Remember, this is going to be a reflection, so it's going to be flipped. When you have your graph, you can check up with mine. Questions? How do we do? Good? Alright, I want you to try number 3. Try number 3 here. See if you can figure this one out. Joseph?
These numbers, here, right from here. So these values left in x-axis that change the y values, their signs. So -2, what's the opposite sign? Positive. -1 became 0, just say 0, and positive 1 became -1, positive 2 became -2. Make sense? Okay. These ones. So for just the y's, we want x's too. Okay, well, if we go right 1, that means we're adding 1, okay? So we just came here with 1 plus 1, 9. We're just using these, yep, we're using the parent table, okay?
Well, this is easy. What? Let me show you.
If the function only x affects the y, then the reflecting of the y would affect the x.
Exactly, because here you're going from positive x's to negative x's.
So like, for example, this first one would just be negative
These
one.
wigs right here. Yeah. Yeah. Yeah.
So this is 3 points.
That would be really good.
Check your table. How are we doing? Good. Vertical asymptote at x equals 0. I'm going to plot the point. So remember, we're going from positive x's to negative x's. So that's the only thing I changed. So here. Oops. 6, 7, 8, 9, 2. Again, I'm still not crossing that x-axis because that's my vertical asymptote. Questions? Let me ask you this. What's my domain here? Good. Negative infinity to 0. That's because you're always going to read left to right. So as you read left to right, do I have my function over here? Yeah, so I'm going to start at negative infinity and go all the way until I hit my vertical asymptote, which is at 0. Okay, so make sure you're paying attention to that. You read left to right. Questions? No? We're okay? Yes? All right. Go ahead and flip it to the next page. Backside. We're going to do it again. So we're going to do it a little bit quicker this time, okay? A little bit quicker. So let's see how quickly we can fill in our parent function if we take a look. Again, 2 to the power of f of x is equal to x. So let me ask you this. What is 2 to the negative second? Negative 4? 1/4. 1 over 4. What is 2 to the negative first? 1/2. Thank you. Anything to the power of 0? 2 to the first. 2 to the second. 4. That took us what? 20 seconds to fill in real quick. So you can always make a table quickly of your parent function. Okay, just take your base, put it to the power of y is equal to x, plug in some exponents, and you can have a table. So let's take a look here. I'm going to do this one differently. So let's plot these points. Let's plot these points here. So we have our vertical asymptote is where?
0.
X equals 0. Make sure you say it as an equation, proper form. 1/4 is at -2. 1/2 is at -1, 0, 1, and 2. All right, I think we're pretty good with the analyzing, yes?
Yeah.
Any part of the analyzing you want me to go over with you? No? All right, so then let's take, yeah, Katie?
Well, on the first side, actually, like when it came to like the asymptotic behavior,
Okay.
for like the second example for the second like transformation, where it was like
What was the-
negative log 3 and then x plus 2.
Okay,
That-
so how about I do it for number 4?
Okay.
So then that way we can see that behavior. Okay? All right, anything that you guys want me to go over with this? Domain is 0 to infinity, range is all real numbers, asymptote x equals 0. We know where to find the x-intercept from the table or the graph. We're good? All right, then let's take a look at number 4. What's one transformation?
Reflection over x.
Reflect over x. Do we have any others? Any others? No. Okay, we only have that one. So we can fill in a table. We know reflecting over the x-axis does what?
Affects the y at the y.
Changes the y values, right? So I can come here and say, okay, well at 1/4, if I see my table here at 1/4, I know that's going to be not at -2, at
Positive 2.
+2. So I'm going to come here and I can just plot that point. I can easily just do that transformation without always filling in a table. You can always just move your points if you have the graph of the parent function, yes? So we have 1/2 is at -1. Where's 1/2 going to be now?
And positive.
At +1. One is at 0. Where's 1 going to be at now? 0. 0 isn't positive or negative. It's nothing. 2 is originally at 1. Where's 2 going to be at now? -1. 4 is at +2. Where is it going to be now? -2. Okay, so if you have that graph or you have that table, you can easily just do those transformations. Draw my vertical asymptote so I know that I'm not passing that x-axis. All right, so let's talk about our end behavior and asymptotic behavior here. Kitty?
The reason why I was a little confused is because since our asymptote wasn't at 0,
Mhm.
it was like moved. So like, how do you know when it like is like technically on the left side or the right side? Does it literally matter where the asymptote is?
No. As long as when you look at your graph and you say, this side's positive, this side's negative, even if the asymptote is over here at like 10, at x equals 10, you still have more positive numbers over here than you do here.
Okay, so it's where you have more.
Yeah, so it's looking at, okay, is it on the right side or is it on the left side?
Okay.
That's all the positive, negative means.
Okay.
So kind of think about, okay, where is it in reference to the y-axis?
Right.
Okay, because that's going to tell you where you have positive numbers, negative numbers. So here, end behavior is the limit as x is approaching what? for n behavior? Positive infinity, okay? Where asymptotic behavior is the limit as x is approaching 0 from
Right.
the right or the positive. So you gotta make sure you have that plus sign in there. All right. Look at my function as x is going to infinity. Where's your function going?
Oh my goodness.
Negative infinity. See how it's going down? It's slowly going down. It's not going down quickly, but it's still going down. So the function is going to negative infinity. Whereas when we get closer to our asymptote, where's your function going?
Positive infinity.
Positive infinity. If that confuses you guys, you can always remember, you're going to have to fill in your domain and range on the graphs. Domain is here. Look at your range. If you know one side, you can see, oh, well, this side's clearly going up. Are both sides going to be going up for a log? No. So if you can fill in one, you can easily fill in the other one. Just use process of elimination. If you already know this side is going to infinity, fill that one in first. Then you can say, oh, okay, well, I wasn't too sure about this one, but since I already used infinity, I can't use that for my ranger again. Because these have to follow your domain and range. Remember that. It has to follow domain and range. Questions? No? All right, what's the next one? We'll do 5 and then we'll be done. So, see if you can fill in your table. Describe your transformation, see if you can graph it. Went left 2, down 1. Can I graph it and be done and say, I'm going to get full credit for this? Why? I have 3 points. So now, how should my log look? Should it look like this?
No, I should go down.
It needs to go towards your asymptote. So make sure it goes down by your asymptote as well. Okay, so make sure you understand what your function actually looks like. All right, let's analyze this one real quick, and then I'll give you your homework to work on. What is your domain here?
Negative infinity.
Do I include -2?
No.
What's the range always?
Infinity, positive infinity.
Because it's always going up, it's always going down. Asymptote is at?
Y equals -2. Or x equals
X equals -2. It's vertical. Where is your intercept at, your x-intercept?
0,
0, 0. Questions on any of that information? All right, I know My end behavior, x needs to go to either positive infinity or negative infinity. Which one am I going to? Positive infinity. If we look there, where's our function going? Is it going for which side of the range? The negative infinity or positive infinity? Positive, it's going up. Asymptotic behavior is always going to my asymptote. One second. What side am I approaching the asymptote on? From the positive or the negative side? Am I approaching from the right, the positive, or the left, the negative?
Positive.
Positive. And where's the function going? Down, negative infinity. You can also think about it this way. For your domain, are you going to positive infinity or negative infinity? Domain, is it positive?